Vectors. Just curious, does anybody know what a vector is? Or like, did you first time learning vectors? Did anybody ever come across the term vectors in any other subject, only in physics? Okay. People who do math, did you do vectors? Or my people in Form 5, did you do vectors yet? Yes? No? Hmm? Not yet. No. Okay. Vectors. Yes, you also see it in physics, right? It's very important in physics, especially in at CAPE. We're gonna be dealing with vectors a lot. So yeah, that's that, right? Hold on, before we get into that, let me show you your syllabus objectives so you know exactly what we're doing. So vectors, it's not really that long compared to some other topics. Vectors isn't really that long. You're required to be able to distinguish between scalar and vector quantities. I'll talk to you about that just now. Express a vector in the form xy or xi plus yj, where x and y are elements of R, so they're real numbers. Define equal vectors, add vectors and subtract vectors, multiply a vector by scalar quantity, use unit vectors, find displacement vectors, find the magnitude and direction of a vector, find the scalar product of two vectors in terms of their components and in terms of their magnitudes and the angle between them, find the angle between two given vectors, and apply properties of parallel and perpendicular vectors. So for people who, you know, matrices, yeah. So for people who never, heard about vectors before, all of that might seem like gibberish, but it's okay. That's what we're going to do, right? If you're going to ask about the last set of questions from last time with integration, don't worry, I still plan on doing them, but after I finish this, right? Scalars and vectors. So when I say scalars, I mean scalar quantities, and when I say vectors, I mean vector quantities. So what exactly are these two things, right? What is a scalar quantity and what is a vector quantity? Well, a scalar quantity is a quantity that has magnitude or size only. For example, distance. Or in physics, you might see speed, time, length. They're all scalar quantities because they only have magnitude. A vector quantity, though, is a quantity that has both magnitude and direction, which is displacement. For example, this displacement, right? So for those who don't do physics, you might not know what displacement is, but basically it's distance in a specific direction. Let me just do a little drawing here. Just remember, I'm not an art student. Don't judge me. Okay? So let's say, I don't know, I have a house. Let me attempt to draw a house. Oh, I wouldn't do it in primary school like this. So let's just say that's a house. And this is a store over here. So this is your house and this is a store. And you have the road, right? Let's say this is the road. This horizontal part right here, I don't know if you want it to be a Mexican shelf or shelf. This horizontal piece right here, let's say it's 5 meters. And then this part right here, let's say 2 meters. So I call you on the phone, I'm in my house. Actually, no. You want to know where this shop is. Josh wants it to be a Mexican shop, so, okay. You want to know where this Mexican shop is in relation to your house. So, where is it? Where is this shop? And I just tell you, oh, well, it's 7 meters away. That doesn't really help me, right? Because where exactly is it? Which street am I crossing, right? So let's say it had a street behind here. So this is my street behind the house. And there's a street here as well. And then there's one right here. So you tell me that the shop in relation to my house is 7 meters away. But where exactly am I supposed to go? Am I passing on this street? Am I passing here? Am I passing here? So that's what distance is, right? The distance would be 7 meters, but the displacement, which is distance in a specific direction, would tell me, okay, if you're at my house, you need to go 5 meters to the right and then 2 meters up. That's where the Mexican shop is. So that's why we say scalar is only magnitude. So the 7 meters, the Mexican shop is 7 meters from my house, of displacement, distance in a specific direction. The shop is 5 meters to the right of my house and then 2 meters up. Do you understand that? Oh my. Mute it. Do you understand that though? Oh my.
Yes, miss.
Okay. So magnitude and direction, right? Displacement tells me to go to the right and up, but distance only tells me how far away it is. Okay. So if you understand that, let's move on now, right? Okay, cool. So same thing with speed and velocity. So my physics students, speed is a scalar quantity, velocity is a vector quantity. But yeah. So that's what we mean. That's what you need to know before we move on. So we're not talking about scalar quantities, right? We're talking about vector quantities. You need to remember, as we move on, you need to remember a vector has both magnitude and direction, right? So representing vectors, how exactly do we represent a vector? We won't just write, this is a vector. There's certain ways to represent it, right? So the first one is a vector diagram. Vectors are represented as arrows, just like you see here. The arrowhead over here. Wait, let me get my little laser pointer. The arrowhead indicates the direction, so it's pointing this way. This is my direction, as you can see here. The arrowhead indicates the direction, and the length of the arrow indicates the magnitude of the vector. So you see however long this arrow is, let's say it's 5 units, that's my magnitude. The length of the vector and the arrowhead tells me the direction, the magnitude and direction. That's the definition of a vector. So that's one way you can represent vectors. Another way is a common letter with a bar on top or below. So let's say, so any common letter, right? So I decided to use V for vector. If I wanted to represent a vector called V, I would write V, common V with a little dash on top, or I could write the common V with a dash below. Let me just write it out here. So let's say the name of my vector is V. Like I said, any common letter, right? If they told me the name of my vector is V, to represent this as a vector, I will put the V with a little dash on top of V with a dash below. That's another way you can represent a vector. Or in print, and when you're typing or something, you're represented by bold letters. So as we move on, you'll see on the PowerPoint that I use the bold letters. Why? Because I am typing. When you're typing or in print, vectors are usually represented with bold letters. There's another way to represent vectors. and it's the right starting and end point with an arrow symbol on the top. So if I told you I have a vector AB, so this whole arrow here, the start point is A, the beginning, which is my tail of the vector. So the vector starts at the point A and then goes all the way to the point B. So this is my starting point and this is my ending point. If I wanted to represent this vector, which is this arrow AB, then I write AB and I put an arrow on the top. So this indicates I'm going from A to B. Do you understand that?
Yes, miss.
Yes, miss.
But if my arrow is going in the opposite direction, so this is my point B and this is A. B, oh my, A, that's a B. Anyways, and instead of going this way from A to B, it goes from B to A. Here, I represented it as AB with that arrow pointing that way to show that it's going from A to B. But if it's going from B to A, then I can represent it like this. B, A, and then the arrow to show that it's starting from B, then going to A. Do you understand that? I know this is kind of, messy, but do you understand what I'm saying?
I have a question.
Yes.
So like basically can we do A, B, and then we draw the arrow going the opposite way?
That's usually that's not usually how it's represented, right? It's usually the arrow always pointing this way. But I mean, technically, it's not wrong. But most
Okay.
times you see it like this. The arrow is always pointing that way.
I understand.
Titania, you had a question? Or you're saying yes?
No, miss, I didn't have a question.
Okay. So I'm clearing this up now, right? And then the final way you can represent, oh gosh, I forgot to highlight it. Anyways, I'll do that after. Another way is the matrix form, a 2x1 matrix, right? So from your math, when you do matrices, you should know that a 2x1 matrix means that it's 2 rows, 1 column. Just like here, this vector has 2 rows, 2 rows, but 1 column, right? And this is called a column vector. So 2x1 matrix, column vector. So you might also see your vector represented like this, right? This value on top tells me the movement or displacement along the x-axis. So positive is to the right, negative is to the left. So if this number is on, let me say -2, that means that I moved 2 spaces to the left. From wherever I start, I move 2 places to the left. If it was +2, then from whatever point I start at, I move 2 places to the right. It's called a translation. When you do that in math, just remember we talked about this. It's called a translation, right? Or a slide. You'll learn about it in math. Don't worry. Then this number below here, it represents the numbers of the y-axis. So movement or displacement along the y-axis. If the number is positive, so let's say I had +4, it means that I move 4 spaces up. If I had -4, I move 4 spaces down. Do you understand that?
Yes, miss.
It's called a translation, right? Or slide. You learn about it in math if you didn't do it yet. So can I move on?
Yeah, you can.
Okay. So, all right. Unit vectors. So we will discuss. Hold on. Right, so we'll discuss more about this whole unit vector concept later on because you need to know it's on a syllabus that you're required to know how to find the unit vector, and this is usually how it's represented, right? So if I have my column vector xy, then the unit vector form would be xi plus yj. Let's say I had a vector AB, so I'm starting at A, ending at B, and my column vector is 2, 3. Then if I wanted to write the unit vector for this, it would be 2i plus 3j. Like I said, we'll discuss that more later down. It's just important for you to know right now, this is how you represent a unit vector. You good? Yes? No? Yep. All right. So let me just show you something real quick before we move on. Say I have my Cartesian plane. Let's pretend that's a straight line. This is my y-axis, right? So we know that the vertical axis. I need to fix this. Vertical axis is my y, horizontal is my x. So bad. But anyway, let me just have a, which is the most common way to represent a factor. Hold on. This is the most common way to represent a factor that we'll be using in a fact. Vector. Oh, I would say this, the column vector. For your exams, that's usually, actually, yeah, I would say the column vector. Column vector, unit vector, and this one right here, with the starting and end point, so the 2 letters and the arrow, yeah, that's what you would usually see in for your exam. So let's say this is my Cartesian plane, this vertical axis is my y-axis, horizontal is my x. So I have my scale, let's say this is 1, this is 2, 3, 4. So therefore this has to be -1, this would be -2, -3, -4. Let's say this is 1, this is 2, 3. This, let's just say this is -1, this is -2, and this is -3. If I wanted to represent this vector AB as a diagram, right? So the first thing we learned about is that vector diagram with the, let me just go back. Vector diagram with the arrow, the head, the tail, magnitude, direction. So let's say I wanted to, actually draw this vector AB. Well, I said, you see that column vector? It's in the form xy. The x, so the value on top, tells me how many spaces I move along the x-axis. If it's positive, it's to the right, negative to the left. Bottom numbers, the bottom number tells me movement along the y-axis. Positive is up, negative is down. So if I wanted to draw this vector AB, so I have my Cartesian plane and I want to draw this vector. So I choose to start at a random point. Let me choose the point 1, 1. So I decide this right here is my point A. How exactly would I go about drawing this vector AB? Well, I said this is my starting point. So this is what I'm dealing with, right? This is my starting point. This right here, this number tells me it's a positive number, right? Remember, the number on top tells me the movement along the x-axis. It's a positive 2. So what does that mean? From my starting point, which is this point right here, I move 2 spaces to the right. So 1, 2. This represents my x movement or x displacement. But I don't stop there. It also tells me that I have to move 3 spaces up. How do I know that? It's positive 3, right? And it's in the y position. So what does that mean? I need to move 3 spaces up from this point here. So 1, 2, okay, so this would be like 4. 1, 2, 3. What does that mean? This right here, this point is my point B. And therefore I could draw my vector going from A to B, and I draw the arrow to indicate the direction. Do you understand that? Yes? No?
No.
No? You said no?
No.
Wait, who told me no? Who said no? Who told me no?
It's me. I just
Okay.
answered, miss.
Oh, okay. Well, we're talking about vectors, right? And I went through all the ways we could represent vectors, and I'm showing you how to actually draw or sketch a vector if you ever required to. Yeah.
Okay, miss.
Yeah, that's kind of a problem since you came in late, so you missed something. Okay. I don't know. Let me do another one, and hopefully you understand. So I choose a random point. I want to. Oh my, bro. I want to draw or sketch this vector AB. It came in late, right? But I was talking about there are different ways to represent vectors. And one of those ways is to represent it like this, right? So if I have AB with that arrow on the top, hold on, people are joining. If I have AB with that arrow to the top right there, this tells me, so this notation right here tells me that I'm starting from a point A. My vector starts from a point A and it goes to a point B. So hold on. When you're doing vector diagrams, it's basically an arrow, right? Vectors can be represented with an arrow. Well, the head tells me the direction and the length of the arrow tells me the magnitude. Because you probably don't even know what I'm talking about there. Did you ever do vectors before?
No, miss. I think I might just have to go over the recording, miss, after the class.
Yeah, because I would have to start all over. Okay, let me just continue. So AB, starting from A going to B, that's the vector they want me to draw. They told me that my column vector is 2, 3. What does that mean? I'm moving 2 spaces to the right along the x-axis, 3 spaces up along the y-axis. So just now, I just chose a random place to start, right? I said I wanted to start my point here, so that was my point A. But if I decided I want to start my point right here, so this is my point A. The coordinates is -4, 0. This is A, right? What this column vector tells me is that B in relation to A is 2 spaces to the right and 3 spaces up. So that's what I'm going to do. From this starting point A, I move 2 spaces to the right. So 1, 2. Then I move 3 spaces up. 1, 2, 3. And therefore, this point right here is going to be my point B. Hold on, this is my point B. B. Draw your lines connecting the two. Remember to put your arrow to indicate the direction. Do you understand that? Yes, no? Okay. Anybody does not understand what I just did? Yeah, practice. So can I move on? screenshot.
Yes, Miss.
Got any? All right, so free vectors versus position vectors. So what exactly are free vectors and what are position vectors? Well, you see what we are doing just now? See these vectors that we're doing? They're called displacement vectors, right? That's like broad name, displacement vectors. But there's special types of vectors. They're free vectors and position vectors. So what exactly is a free vector? What is a position vector? Well, you see displacement vectors. So if I start a vector at any point on the plane, just like I did just now, first I started my vector at the point 1, 1, and then I started it at the point -4, 0. So I chose wherever I wanted to start that vector from. That's called a free vector because I started anywhere on the Cartesian plane. However, there's a special type of vector called a position vector, and this type of vector must start at the origin. For example, if I have, say, my position vector OA, that's how you represent a position vector, right? So this is generally how you represent position vectors. You have the capital O and then whatever letter, right? So let me say, which is more common, free or position. Oh my gosh, what is that? For your exam, it would be position. And you see what I'm talking about when we actually start the past paper. See, this thing is not working right. Right, okay, nice. So say I have a position vector OA. I don't have it on the PowerPoint, but I would add it in. Remember your arrow on top. I have a position vector OA. This is generally how position vectors are represented, right? You have a capital O, so it always starts at O to indicate that it's starting at the origin, and then whatever point it's going to, right? Whatever is the ending point. So say I have my Cartesian plane again. This is the Y, we know that. This is my X, we know that. 3, 1, 2, 3, 1, 2, 3. It's not really supposed to be passing there, but anyways, 1, 2, 3. Oh my, it's raining. Anyways, can you hear me clearly? Because it's raining now. All right, cool. So this is my Cartesian plane, vertical axis.
Yes. Yes.
Okay, can't hear it. Okay, cool. This vertical axis is called my y-axis. We know that. The horizontal is the x-axis. We know that. So I put my scale. This would represent 1. This is 2, 3, -1, -2, -3, 1, 2, 3, -1, -2, -3, right? Unlike what we're doing just now, where I chose a random point, I was like, okay, I know I'm starting. So before we had the vector A, B, right? And I was like, okay, I know I'm starting at the point A and going towards the point B. So I chose any place on the plane, Cartesian plane, to start my point. The first thing I did, I said, okay, I want my A to be right here. I want to start here. And then in the second example, I started A at this point, right? That's called a free vector because I chose anywhere on the plane to start. I just decided I wanted to start there, right? Position vectors are different though. Position vectors must start at the origin. That's why you always see that O there. The O represents the origin. So I'm starting at O, which is my origin, and I'm going towards A, which is the other point. So if I wanted to represent this position vector, let's say they told me that the column vector for this is I know, let's also do the 2, 3. So the column vector to represent this is 2, 3. Unlike this one where I chose any point and then I did whatever, I have to start at the origin. So I have to start right here. And then using this point, I can do whatever, right? So positive 2. Positive 2 tells me 2 spaces to the right. So from the origin, 1, 2 spaces to the right. Then they told me 3, positive 3. So that's 3 spaces up. So I said 1, 2 spaces to the right, 1, 2, 3 spaces up. And therefore, this right here is my point A. This is O. The position vector tells me I'm going from O to A. And therefore, I would draw my arrow going from O to A. And I put the arrow to show that I'm going from O to A. Do you understand that? Yes? No? Yes?
Could you go over it once more?
All right. Oh, I've less than a minute. Rejoin. Okay. Let's rejoin.